Today I'm going to show you how to do systems of inequality word problems or application problems. You set them up just like systems of equations. So that first paragraph talks about how we've already done systems of equations and that you're going to set it up the same exact way. The only difference is you're going to have shading involved. So you could have multiple answers because they all fall in a shaded region. Some differences you're going to note are if it's infinitely many solutions, meaning the whole thing is shaded, dashed versus solid. A dashed line means it cannot be that solution. A solid line means that it can be. So your inequality signs, your keywords, less than and fewer than go with the less than symbol. Greater than and more than go with the greater than symbol. Less than or equal to, at most, no more than, or less than or equal to symbol. And the last symbol would be greater than or equal to, at least, no less than, all go together. So as you go through, that's a good reference to have handy. Chip can work no more than. So there it is right there, no more than. There's our key word there. He can work 25 hours each week. Dog sitting pays $4 per hour, and mowing lawns pays $8 per hour. He needs to earn at least $96 each week for his data plan. So first we're going to define the variables. We're going to let X equal the number of hours dog sitting and Y equal the number of hours mowing lawns. So total number of hours has to be less than 25, less than or equal to 25. So our first equation is X plus Y is less than or equal to 25. He wants to earn at least $96. Well, he's going to make $4 dog sitting, so there's 4X. He's going to make $8 mowing lawns per hour, so that would be 8Y, is greater than or equal to the 96 he'd like to make. You're then going to graph the system in Desmos, which I've done over here, and you see I only see the pink, so I have to zoom out to see the whole thing. So there's the whole thing. So the solution set is this double shaded region, this triangular section right here. That will give him both things. That will make sure any point in here, so his dog sitting is down here and his mowing lawns is the y-axis. Any of these ordered pairs will make both of these true at the same time. Anything in here will be less than 25 hours and making more than $96. So when I solve it in Desmos, I'm going to screenshot it and put it in my assignment. And then the follow-up question says identify two possible solutions. So going over here to your calculator, you can pick any one in this double shaded region. Don't pick any one out here in the pink. Don't pick one in the blue. Make sure it's in this purpley region. And the white down here is neither. So two examples I gave here, 10 and 10. He could work 10 hours dog sitting, 10 hours mowing lawn. He'll earn at least $96, but won't work more than 25 hours. And the other example is he could work 4 hours dog sitting and 20 hours mowing lawns, and that would fall into it as well. Please make sure you give me a complete sentence there to define going back to defining those variables. Example number 2, Shonda wants to purchase some pencils and pens in her school annual store. Pencils cost $2 a pack and pens cost $3 a pack. Shonda wants to buy at least, there's your keyword, at least 4 packs, but only has at most $15 to spend. So there's your two inequalities from the top. So I decided to let X equal the number of packs pencils, Y equal the packs pens, write my system. X plus Y is greater than or equal to 5. 2X plus 3Y is less than or equal to 15. So total packs has to be, there's a typo there, at least 4. And the money part as less than or equal to 15. So typing that into my Desmos calculator and taking a look at that, it's that triangular shaded region there. And the follow-up question here, you can do it one of 2 ways based on your equality: 4 packs of pencils, 2 pens. If I go over here, go over to 4, up to 2, that's in the double shaded region. Or you could type them in, substitute them into the 2 inequalities that you wrote. And if they're both true, the answer is yes.